Hello nerds, coming to you live, or by live I mean on tape delay, from my new command station here up in the attic. I gotta admit, a lot better recording at night because it gets really effing hot in the attic during the daytime. Even with the air conditioner up here running, I couldn't get it below about 89 degrees today. So this is a new assignment that I've put together for learning C Sharp. Let me go ahead and run it for you. Let's see. Compile all the C Sharp files, and then I think it's called adventure.exe. Yeah, okay, so watch this. With WASD, we can move around. As you can see up here, I am the little, and what is that, a at sign? And then this is the monster, the little pound sign. And I'm moving around. See, I'm trying to move down. I'm hitting S to move down. Nope, crashing into that. These are walls. Can't go off the edge. That's the border. That's the treasure there. I'm trying to get that before this thing gets it. I got it. If I hit my inventory, V, you have nothing. Oh, I need a new line there. So that didn't really work. Now let's go watch what these monsters are very stupid. They move randomly. So I'm going to try to get it to kill me. Yeah, it got me. See, look, and then it changed it from a pound sign, or a hash sign, I should say hashtag, because that's what all the kids these days are into their hashtags, into, what is that, an asterisk? To show that I've been splatted. The monster got me, which is kind of cool. Oh, something else I should show you. Let me run that again. So I can move around. This monster literally just wanders around randomly. IJKL is to interact. So you can see I'm hitting IJKL. It doesn't really do anything. Oh yeah, see, I hit K downwards and it grabbed the treasure. So that's like to do actions in different directions. The actions don't currently do anything. Right now it just says negative. That's really weird. I need to put a new line there. That looks strange. Anyway, so that's what's happening, and if you hit Q, it'll end. So, very exciting text-based adventure. Like, we're solidly into the 1970s. So, let's sort of do a top-down dive into how this works. So the first thing that we're doing here in C# is I've put all the code, I've split it across 1, 2, 3, 4, 5 different files, but I've put it all in the same namespace. This is, why did I do this? I don't really know, because I'm experimenting with namespaces in C#, so I decided to call it asciiadventure. That's the name of the project, that's what's called on GitHub. So I've got namespace, asciiadventure. This is creating a namespace, and then everything in here is in that namespace, right? So everything all the way down, because if we like put our cursor here and then we scroll up, you can see it's highlighting that. Boom, everything's in the namespace. What's interesting is if you look at everything here in screen, we also have the asciiadventure namespace. So I've sort of put everything in the namespace, the same namespace. Namespaces in C# are approximately equivalent to packages in Java. The difference being in Java, if you have a package, you also have to have a particular folder structure that goes along with it. You don't need that in C#. You can just have, whatever you want, and C# will figure out the namespace based on the actual namespace, not based on some sort of like package structure. So in Java, you would have to say like, Nox dot whatever, and then you would have to have a packet, a folder structure like Nox slash something. You don't have to do that in C#, right? The namespace is just an abstract namespace. So all these files are in the same namespace, even though they're separate files. All of the code that's in them. So I went ahead and called. So this first one, adventure. I don't know why I called it adventure, just because like this is like adventure. I should have called it asciiadventure, but whatever. I called it adventure. So what do we have in there? Well, we have public class game. The game is the sort of like thing that runs the entire game, sort of owns all the major objects and runs it. So you can see we've got some instance variables here, a random number generator, very standard. We've got some static helper methods, like this generates the menu, which is not terribly, like you could change this function to make a more sophisticated menu. This is a helper to check if like two characters are equal to each other. Why did I? Oh yeah, I want to do a case insensitive. So like I want uppercase W to be the same as lowercase w. So like I just had this EQ function, and I'm converting this to a string, and then checking if it's equal to the other string. but I'm doing this ignore, case. So that's a useful thing. So it lets me check if like I've got a lowercase w or a capital W. Doesn't matter. Just got one function. Print screen. What does this do? Oh, right. This actually like literally prints the screen. Like the entire game board, which has like a game board, a menu, and something else. Oh, a game. Yeah, here's the board. Here's the message. Here's the menu. And the way I'm getting the movement, the way things are moving around, is I'm clearing it every time. So like, you can't see it happen. It's faking animation, but I'm clearing the screen after every move. So this clears the screen or clears the console, and then this just sort of reprints everything. So here's what's happening with run. The way I'm getting the green color is I'm setting the foreground color to green. That's how I'm getting this like lovely green color for everything down here. The walls that I have, if you look down here, it's got these walls. Why are those there? I don't know. I just wrote some for loops and stuck in some walls. We'll talk about wall in a second. That's a specific class that's in game objects over here. We'll talk about that. So I just went ahead and wrote some for loops to stick in some walls. Player, that's the player. I'm starting out at 0, 0 in the screen. What screen is it? Well, don't I have a variable for screen? I don't yet, but I will, oh yeah, here it is, screen. Screen, this is the game board. It's 10 by 10. So if we look down here, this is a 10 by 10 game board. Now what's interesting is if we count up here, 1, 2, 3, 4, 5, 6. Well, that's a lot to count. Basically, it's 10 by 10 in here. This is 10, and then this is 10. And then it, like, my toString just basically, like, prints the border around it. So the border is not 10 by 10. It's probably 12 by 12. But the actual space within the game board is 10 by 10. Yeah, so we have this 10 by 10 screen. Screen's another class that is over here, which we'll talk about in a second. So we've got a player. I started the player at 0, 0. That's the top left. I'm not doing XY coordinates like so many things in computer science. I'm doing rows and columns just because we have to print from left to right and top to bottom because that's how consoles work, so that just makes it a lot easier to do it that way. The treasure I just put at 6, 2, so that is row 6, column 2. I've got a mob, that's the monster, that's in this mob class. I put it at this particular location, 9, 9, so that's the bottom right. And then print screen, remember that shows the original thing, so here's the initial screen, the message is welcome, it prints the menu. Then I've got this loop, this is the main loop here, so Boolean game over is false. So while it's not game over, do all of this. What am I doing? Well, this reads a single key of input. Now, if you notice, I was just, well, you probably didn't see this, like, because you weren't, like, watching, but I wasn't hitting, like, W enter to go up and S enter to go down. I was just hitting WASD, and it was moving. That's because I wasn't reading up until a new line. I was, like, just sort of, like, setting read key to true, and then getting one character. This is how you read a single character of input in C#. How did I know this? Well, I'm just really smart and I know everything. No, I'm kidding. I Googled it. Like any programmer knows anything, you Google stuff. So this big set of this is the message. So like basically that's like this stuff down here. What message do you want to show? Initially it's empty, and then potentially like some of the things down here add some stuff to the message. Oh, this is what's going on. I don't actually add a new line. I might try to fix this. Oops. Just because I'm such a uber amazing hacker like that, right? Okay, let's try this. CSC star CS mono. Okay, now let's try with these buttons. Yeah, see, look at that. That's fantastic. Ha! Did it. Good. Okay, now I'm gonna git diff n is adventure. Okay, git add adventure.cs git commit -m. What did I just do? I added new lines after directional action messages or something like that. Good. Now git push origin master. Good. Okay, see, you got to see some command line git there, so lucky you. Good. Okay, so right now we're checking. Here's where this. So input is the character that they entered, And then here's where this EQ function, right, which just does a case-insensitive comparison. So like if it's capital W, lowercase w, whatever, doesn't really care. So if it's Q, we just break. What does break do? Well, that just ends this loop. So that's equivalent to, you know, setting game over. That's just like, boom, loops over, game's over. WSAD, we're moving. This method is we'll go over this method. This is the move method in player. So -1, 0, this is the rows, this is the columns. So remember, W is to move up, right? So if up means you're going, rows are going negative, because if row 0 is at the top and row, you know, 9 is at the bottom, because we have 10 rows, 0 through 9, then if you're at like row 5 and you move up, that goes to row 4. So that's -1 in the you know, up in the rows, and of course moving down would be positive in the rows. And then same thing here with columns. You know, moving left is negative columns, moving right is positive columns. And then the same with the actions. And so basically an action, this is a method of the player class. We'll look at these. This just tells the player to move. This tells the player, like, do an action. So an action could be like an attack, it could be picking up a treasure, it could be breaking one of the walls, like it could be any number of different things. This is open. This is an open-ended assignment. You can like do whatever you want with the actions. I don't really care. You know, right now it doesn't actually do anything. It just like says, okay, do this action, and then the action returns a string which it adds to the message. Right now the action just says like negative if you move in any direction, or it says nope if you try to move, you know, action off screen, and the only thing you can do is grab the treasure. V is for inventory. There's a to-do here. It doesn't do anything. It just says you have nothing. We need another new line here. Let's fix that. Git add adventure.cs, git commit-m, more new lines, git push origin master. Good. Okay, that looks much better. And then if you enter something it doesn't understand, it'll just say unknown command. And remember, in C#, if we put a $sign and then we have a string and then we have something with like these curly braces, this is an interpolated string, so it's going to look up the value of the local variable input. Ooh, in my thingamajig, what is this called? VS Code is actually highlighting that for me. That's fantastic. So, you know, if you enter something like, you know, P, which it doesn't know, or B, it'll say like unknown command P or unknown command B. So this is basically the player moves. Once the player's moved, the mobs get to move. Remember, there's just one mob, which is at 9, 9, bottom right. So I've got this for each loop. We go through each of the mobs. We have a list of mobs, right? Because remember, up here, we created a list of mobs. We just added one. You could have more if you'd like. What do the mobs do? Well, we can ask the screen, which is basically the grid, to get all the legal moves for a particular row and column. So we're saying, like, okay, we know the mob is at the given row and column. These are getters in C#. So it looks like these are variable accesses, but they're really getters, because C# has a really good syntax for that. In Java, you'd have to say get row and get column and set row and set column. In C#, you basically have those methods, but it looks like you're accessing a variable, but you're not really accessing a variable. You're using a getter method that gets created for you. When we look at mobs, we'll sort of look at that code. So the screen knows how to say, get me all the legal moves, and it returns a list of the legal moves it could make. Now the moves are, you know, it's a list of tuples. Tuples a built-in class in C#. And the two ints here, it's basically this stuff, right? So it's going to tell you, you know, for something located at the given row and column, what moves could it make? Well, at most, this list could have 4 things in it, right? Because if it's in the middle somewhere and there's nothing around it, it could go up, down, left, and right. We don't allow diagonal moves. Why don't we allow diagonal moves? I don't know, because I didn't allow diagonal moves. So if this list comes back empty, that means there's no legal moves. Maybe you're like somehow stepped on a trap and now there's walls all around you. I don't know. So there's no legal moves. It'll just continue. Continue, remember, just goes back up to the top of the loop and goes to the next mob. Otherwise, you know, here's what we're going to do. We're going to take this moves, which is a list. We're going to index into the list, and this is a super cool thing we can do in C#. So in C#, moves is a list. In Java, you can only use square brackets with arrays. In C#, haha, you can use square brackets with arrays, with characters, with lists, with dictionaries, with a number of other classes, because it allows you to override the bracket operator. So we're indexing in, we're saying like, get me a random number between 0 and count -1. This is basically the size. So if there's 3 things in there, if there's 3 possible moves, maybe you're up against a wall, so there's 3 moves you could make. Well, random.next is just like in Java. It's going to tell you 0, 1, or 2. So it's going to sort of randomly pick one of those. Here's a cool thing. This is called destructuring. It's going to return a tuple, which has 2 ints in it. Tuple is like just basically a class that contains 2 values. This destructures it. So this basically says like, okay, I know I'm getting back a class with 2 values, and I know they're ints, and I want one to be delta row and one to be delta column. Delta meaning change. Not the airline. And this var is another thing you can do in C#. It's telling C# like, I'm not going to tell you the types. You should be able to infer the types because there's enough type information, here and everywhere else that it should be able to figure out. If it can't figure it out, the compiler will let you know and be like, var wasn't specific enough. You need to give me more information. But in this situation, I'm pretty sure, I know it'll figure out because we tested it. So we get this back. So it's randomly picking a move. And then what are we doing? Well, we're going to say like, okay, if the new location, meaning wherever the mob was before, plus the change in row, and the mob column plus change in column, if that's the player, and this is super cool. This is believe it or not, is just a getter. This is, we've got a square bracket here. Remember, the screen is essentially a grid, and we want to index into that grid at a given row and column. This is essentially overloading like the array index operation for what looks to be a 2-dimensional array, but isn't really a 2-dimensional array. It's really our grid class, or our screen class, as we're calling it. So this gets it at a row, plus a particular row, column, plus a particular column. So it's sort of like, get me the thing that's at that location, which is going to be a game object, which is sort of a base class. And this is something you can do in C#. It's saying like, okay, if the thing here, the instance here, is of type player, meaning like the mob randomly moved and landed on a player, what are we going to do? Well, set the mob's token meaning how are we rendering it on the screen. The token for the player was a @. The token for the mobs was a £. If we get the player, we're going to change it to this splat to let us know, like an asterisk, like we splatted the player. The player's been eaten by the mob or whatever. And then we add this to the message. We set game over to true, so that's going to sort of like end things. I don't know why I was adding this. This was actually probably this can go. Let's kill that. Yeah. So basically, like, if the move gets to the player, set these extra things. Otherwise, just sort of like tell the mob to make the move in the given, like, change in row, change in column. And then we get back to the top of the loop. And so either we will have, quit or exited or eaten the player or something like that, in which case game over is true, and that'll break out the loop. Or we do the whole thing over again. And then, no. Is this the bottom of the loop? That's the bottom of the loop. What is this? This is the for each loop for the mobs. Right. Okay. Yeah, so it'll move each mob. When we're done moving all the mobs, we reprint the entire screen, right, which reprints the grid, which is screen, the message, which we've modified by adding stuff to the message, and then this is just calling that static menu function to sort of generate whatever the menu is. Like, you can change this however you want to do it. And then eventually, we either hit Q to exit, or we splat the player, and game over gets set to true, and then the whole loop ends. And, once the entire while loop here ends, that just sort of ends the method, which makes everything basically done. And so you can see that's the run method in game that's kind of like doing all the work. We could actually make screen like an instance variable. It perhaps should be an instance variable. Right now it's just a local variable inside the run method. We could make the player an instance variable. We could make the list of mobs an instance variable. There's actually a lot of really cool innovations we could do. I just sort of like stuck everything in run just to get it working. And if you look at what the actual main method does, it just creates a new instance of game and just tells game to run. Is this the only way to do things? No, but it's the way that I structured things, so that's what we've got. Okay, great. So that is the game class. That's kind of like the very top. Now let's look at screen, which is the grid that's going to draw everything. So again, it's in the asciiadventure namespace, public class screen. Why did I call it screen? Because it's like a screen. I called it screen because I'm thinking like one cool thing would be to like get to the edge of the screen and go to the next screen. So have like a grid of screens somehow. But I never got around to building that. You can build that if you want. That would be a really cool way to do the project. So what instance variables does this have? Well, look at this. Private game object, grid. This, believe it or not, in C# multi-dimensional array with 2 dimensions, right? So if we just said game object bracket bracket, that would be like Java. That would just be like a 1-dimensional array. But since we have bracket comma bracket, that's telling us it's a 2-dimensional array. We don't know how big it is. This is just a reference, but we know that grid is a reference to a 2-dimensional grid of game object. Game object is kind of the base class. We'll see that when we get over to here. So like it's a base class that we can use. So the subclass it has include walls and players and treasures and mobs. Those are all game objects. Game object is something that could be on the grid. And anything that's null, well, that's just an open square. So if you let me go ahead and run this again. Mono. Right, so if you look at this, these are all null for the game object. Obviously, these are instances of wall. This is the wall. This is an instance of treasure. This is an instance of mob. And you notice everything just sits here until I move. And then as I move, or, take actions with my IJKL, which is directional actions, and then watch this. Boom, ha! See, we got the treasure. If I hit my inventory, oh, I didn't recompile it, I think. It doesn't really tell me anything about my inventory. Like, I didn't implement how to grab the... I just, it grabs the treasure but doesn't do anything with it. It's fine. Anyway, I can't remember why I was telling you that. Right. Game object. So, these are null game objects, which my brilliant print screen for screen knows to, just leave as open squares, and then, wall game objects know to print themselves as equal signs, and the player knows to print itself this way, and the mob this way, and the treasure was T, and so on. So here's where some of the cool C# stuff starts to come in. Num rows and num columns. I'm declaring this is public int num rows. Is this an instance variable? Is this a method? What is this? Well, this is kind of all of the above. I'm saying that I want to have something that's a public int num rows, and then I've got these brackets saying, and I'm saying okay, I want to have a get method for it, which means it's public to get it, but I want the set method to be private. So I only want things that are inside the screen class to be able to change the number of rows, right? So get is public, but set is private. And so rather than creating a private instance variable called num rows, and then doing public int get num rows and returning it, whatever you would do in Java, generating those get and set methods, we just say it's called num rows. It has a public get, or I'm not leaving off the modifier, which it's going to assume that it's public, and then a private set. So you can't just set num rows and num columns. This goes ahead and figures out everything else, and so now when I have an instance of screen, I can just go screen s new screen blah 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 s dot num rows, and I don't even need parentheses. It looks like an instance variable access, but it's really a method, because this is telling it okay, you're going to be a method. So it's a really cool way in C# that you can automatically generate get and set methods without having to write them yourself or tell the editor to write them. Here's the constructor for screen. We give it a number of rows and a number of columns. Look at this. numRows with a capital N equal numRows lowercase n. Well, the one with a lowercase obviously is this one. The capital, that's this. Why am I able to assign it? Well, because it has a private set. Private means it has to be within this class. Well, the constructor is obviously within the screen constructor is within the screen class. So these two sets are illegal. But if I were to try to be outside of screen and reassign, numRows, it wouldn't work. Now we're also, once we know numRows and numColumns, we're saying like this.grid, again, that's the instance variable up here, is new game object of numRows and numColumns. This is just a two-dimensional array creation. And in the same rules in Java, if you don't initialize something, it's going to assume it should be null. Now we have all of our... Oh, and there's a lot of code in here. Ugh. Well, whatever. This took me a while to figure out. So, is legal move? If you're at a given row and column, and you want to move, change your column by a certain amount, change your row by a certain amount, and your column by a certain amount, well, let's figure out what the new row and column would be and check if it's in bounds. This is another helper method we have in here. So if it's not in bounds, return false, meaning that's not a legal move, right? So if you're up against the edge of the screen and you try to move off the screen, this is in bounds, going to detect not in bounds, it's not going to work. If this didn't return false, then we know it is in bounds. So now we have to check, okay, if I were to make that move, is there another game object there? Well, let's get the game object at the new location. We'll explain this in a second. I've overloaded the bracket operation, so again, this is just saying like, it's saying like, get me whatever game object is in my grid at the new row and the new column, where these are just sort of in. So it's basically going into this instance variable and getting the thing at one coordinate, the other coordinate. And I'll show you how this is implemented in a second. If it's null, return true. Null would mean there's nothing there. Otherwise, if it's passable. So game objects have this isPassable method, which lets us know, like, can I walk over it? So walls are not passable, treasures are. You can walk over the treasure. Unfortunately, anytime you walk over the treasure, it disappears because it replaces it with the player, which is kind of a weakness of the structure I have, but I don't know, we can figure that out. So if it's passable or it's the player, it's a legal move. This is necessary so that monsters are allowed to eat the player. Because the player's not passable. Maybe, actually, we could just make the player passable. I don't know. Maybe that would also do it. So the monsters can walk over the player. That would work too. Okay, this is get legal moves. So for row and column, we're going to check all the possible moves. So if it would be a legal move from row and column to go up one row, then in moves add tuple.create. This creates a tuple with this is the first variable, this is the second variable, because again, this is the type. It's a list of tuples of int and int. So, we're basically looking at all the possibilities. Can I go up? Can I go down? Can I go left? Can I go right? If any of those are legal, it adds it to the list of moves and then returns it. So this is that method that's called by the mobs when they're moving randomly, and they're like, give me all the legal moves, let me randomly pick one of those. This is super cool. This code here is why up here this works. So what we're doing is we're overloading the array index operation. So we're saying, okay, public game object, so it's a public, get me back a game object, but we're saying this bracket row column, right? So this, again, is just the keyword. The current object, if you use brackets with two values, in other words, you treat this instance of screen like a 2D array, here's what I would like it to do. So if it's a get, then we're going to check if it's legal to use row column. I'll show you this function in a second, and then return whatever's there, right? So if it's a legal move, return it. For a set, if it's a legal move, grid of row column equal value. Now value is interesting. There's nothing in here called value. That's just the default name because we're overloading the bracket operation. What can you do with brackets with an array? Well, you can get the thing. You could like do, print the thing at array bracket 0 in Java, right? That's a thing you could do. Get me the thing in the first position. Or you could say array bracket 0 equal 5. Assign 5 into that. So for get, we're just going to like return whatever's there. For set, we're going to assign to that location the value. So it knows for a set that you have to be assigning it something. You'd have to be doing like array 0, 5 equal, 7 or something like that. So that 7 it knows to assign that to value, which is super cool. So this use row and column, check row, this just checks if a given row, these are protected. Protected is kind of like private, but it's also usable by subclasses. These are helper functions, so is a row legal? Was legal if it's greater than or equal to 0 and less than the number of rows. Again, this is that magic getter function. It looks like it's just accessing an instance variable, but it's not. It's actually calling a method. And same with column. Column's legal if it's greater than or equal to column and less than the number of columns. And remember, it's less than because we start counting at 0. So if there's 10 columns, it's 0 to 9. So 10 rows, row should be less than 10, so up to 9. Is in bounds. What do we do for this? Well, check row and check column. These both return Boolean. Both of those have to be legal. If that's legal for given row and column are in bounds. So these are all of our sort of helper functions. You notice this one is not marked protected. It's marked internal. The reason I had to do that is I needed to call it from some other place. So I want this to be, so internal is something you don't have in Java. Internal means it's usable inside the assembly, which means the executable that we create by compiling it. So anything that's in that executable can use it. But if we create an executable, or in Windows it would be a DLL, dynamic linked library. On Mac it would be a dylib, a dynamic library. So if you were to create some like, actually that would be for C. I don't know what it would be called for C#. If you were to essentially like create a compiled file, what is that called? CLR? A CLR file, and some other thing were to using it, basically means import, then you couldn't see things marked internal. So all the stuff that gets compiled together can see stuff internal, but other stuff can't. So I can't remember where I needed to use that, but I needed to use it somewhere. Yes, that's internal. So that's just another fun fact. Use row and column. This is interesting. So is in bounds just uses these check methods and returns either true or false. Is it in bounds? Use row and column says, like, I'm going to put something in a row and column, and if I can't, I need you to crash. So if the row is illegal, this throws a runtime exception and says, hey, this row is out of range. And same thing if the column's illegal. So this function gets called, where was this called? I'm getting tired. I might have to stop and do the other classes later. I can't remember where it was, but it gets called somewhere. Right, so is in bounds just says like, hey, is this legal? True or false. Use row and column says, I'm going to use this. If it's legal, do nothing. But if this row and column is somehow illegal, throw an exception. Right, so this is stronger than this. This will crash if it's not legal. This just returns false. And so those are used in different contexts. I don't think this ever gets called. I'm pretty sure this doesn't get called. Probably could get rid of it. Here's the other final cool piece. ToString. Okay, so we have this two-dimensional grid of game object. A lot of the game objects are null. That means it's an open square. Some of them might be player. Some of them might be mob. Some of them might be wall. Some of them might be treasure. Some of them might be other things we haven't yet created. How's this going to work? Well, I'm creating a thing called a string builder, so I don't have to do string concatenation. A string builder is like a string, but it's highly optimized for like a whole lot of concatenation. This is just generating, essentially, like if we look down here, a plus, enough dashes, one for each of our number of rows, and then another plus. We're going to do the same thing at the bottom, and then for each row, we're going to do a vertical bar, the row, and then the vertical bar. So that's like literally, this does this for the top row. This is a super cool string.concat enumerable.repeat dash number of columns. So this, like, is just a really cool C# way to say, like, I want you to give me this many number of this character, go. And then once we have those, this string.concat is saying, like, okay, take the result of all this and, like, concatenate it all together. and then so we're appending a plus, all those dashes, another plus in a new line. Now we're going through each of the rows. We're going to do the vertical bar, then go through each column in that row and get whatever's there and then append it. So if it's null, we're just going to leave it as a space. If it isn't null, then get its token. Now, GameObject2Token, this is a method that all game objects have. So, player obviously are returning the @ sign, and monsters are returning the hash sign. Walls are returning the equal sign. So, like, each thing can have its own token, meaning like its own string for how, well, one character string, really character, how to represent itself. Yeah, and then at the end, sort of append this and then the new line. And then this just does the same thing, essentially another one of these, and then return like result. What is result? What's the string builder dot toString? So this is the toString method. And if you notice, the toString method, so in Java, you would just call it toString, whatever. Here, like in Java, this override would show up as a annotation. Annotations are stronger than comments, but weaker than code. In C#, it's actually part of the language. Override is a keyword in the C# language, right? So if you're going to override a method, you have to put in an override. And if you put in this override keyword, you have to be overriding a method. You can't, C# doesn't allow you to get that wrong. Yeah, so that's everything with screen. I unfortunately am exhausted because it's after midnight and I need to stop. So that's part 1.